Welcome to your lesson on pyramids, cones, and spheres. This video will be jam-packed full of information, lots of math words and important concepts. Buckle in and get ready for the ride of your life. Let's get started. This video is going to concentrate on what are geometric solids and how are they different than polyhedrons. We're going to talk about volume of geometric solids, and then we're going to finish with surface area of geometric solids. Geometric solids. They are basically 3D shapes, right? So which of these nets match these? Let's go with this one. Which one will this one be? Great. I hope you can match all of them quickly in your head. These are pretty easy to match, these nets, which are two-dimensional representations of these 3D solids. Okay, to classify, solids come in two main types: prisms, which look like this, and pyramids, which look like this. But in each of these, one doesn't belong. Which one is it in this row? This one here. It has rounded faces, whereas the rest are all polygons. How about in this row? This one. Again, it has a rounded face. That's different than all the other ones, which have angles and polygon faces. With that in mind, let's classify these. We have polyhedrons and curved solids. Curved solids are the ones that have rounded faces. So that cone is a curved solid. This sphere is a curved solid. This cylinder is also a curved solid. It has curved surfaces. Now prisms are polyhedrons which have two bases that are identical. So a cube can be a prism. This rectangular prism is a prism because it has two bases that are identical. Pyramids don't have two bases that are parallel to each other. They just have one point that's called an apex. So that's a pyramid. This is a pyramid. This green one here is not a pyramid. This one is a prism. Notice it does not go to one point on top. The front and the back are actually two congruent parallel bases. That's considered a polyhedron. So there's a general classification of geometric solids. Let's keep going. With that in mind, let's go into some other words we should know. So what is a polyhedron exactly? We're just looking at it. Well, to give you a hint, this man is in a polygamous relationship. What do you think poly means? And this mythical Greek monster is called a hydra. It comes from the word hedron. What do you think hedron means? All right, put poly and hedron together. Poly means many. Hedron, faces. Shapes with many faces are called polyhedrons. Okay, so shapes with three dimensions, length, width, and height, are called solids. That's all 3D shapes. Polyhedrons are a specific type, which have polygonal faces, so all the faces are polygons, and they connect along line segments that are known as edges, and the edges meet at points called vertices. TOK question: what are platonic solids and why are they important? So maybe pause and take a quick online look at platonic solids. What do you find? Okay, let's define some things. A prism, it's a polyhedron with two congruent parallel polygon bases. These are all prisms. Prisms are named by their bases. For example, triangular base, triangular prism. Rectangular prism, square prism. Pentagonal prism, and hexagonal prism. Notice again, two parallel congruent bases. The remaining faces are called lateral faces. 3 of them here, 4 of them, 4 of them, 5 lateral faces, and 6 lateral faces. The height of a prism is the distance from base to base. Okay, a pyramid is a polyhedron with one polygon base. So this time there's not two parallel bases, there's just one. And then triangular faces that meet at a common vertex called the apex. That's rectangular pyramid, pentagonal pyramid, and a triangular pyramid. And the height lines go down from the apex to the center of the polygonal base. A cylinder is a solid with two congruent parallel circular bases. It's not a polyhedron. Why? All right. A cone is a solid with a circular base and all the segments from the vertex to the circle. It's not a polyhedron either. Why? Okay, so the three types we're going to concentrate on are pyramids, cones, and spheres. Notice this pyramid has a triangular face here. There's the base down there. it has what's called a slant height, and it also has a height line down the middle here. And there's your apex. And in a cone, we have very similar things: the vertex, a height line, a slant height along the side here, and a radius here. Notice that pyramids and cones obviously are very similar. A cone is kind of like a curved version of a pyramid. Okay, so these are solids, polyhedrons. These are all curved solids here. We have a sphere, a hemisphere. Notice this one's called a tetrahedron. It's also a triangular pyramid. Tetra because it has 4 faces. Okay, volume. Let's talk about volume. So we have perimeter is a 1-dimensional property, area a 2-dimensional property, and volume is a 3-dimensional property. Okay, if each of these nets was folded into a box without a lid, so imagine these flaps were folded up, then how many cubes would fit inside each one? Try that for A, B, and C. All right, good work. So let's talk about volume. What is volume? That last question was to introduce you to volume. Volume is basically how many little cubic units can you fit inside a 3D shape. That's what volume is, the measure of the amount of space or the number of cubic units that a solid contains. How many cubes can you fit in there? Volume can be thought of this way as well. We have the base of a shape, and we can find the area of that base. And then you stack up layers to make that shape into a 3D shape. So the number of layers times the base area is your volume. So think of volume that way. Always think of it as stacking bases. So volume of a prism. We have a base area and we're stacking it up. And that stacking motion shows us the height. So volume is base area times height. Base area times height. Let's look at it over here. Here we have a triangular prism. Stacking bases again. There's the bases. Stacking them up along the height line. The volume then is base area times height. Or the area of that triangle on the bottom times the height. Okay, volumes of cylinders work the same way. We have the base area, which is a circular area, pi r squared, and we're stacking it up in layers. So volume of a cylinder works the same way. Base area times height. Oh, let me run that again. Here we go. Here's the stacking of the bases up the height line. Volume, base area times height. In this case, our base area is pi r squared times height. Okay, now let's talk about pyramids. Pyramid volume. Well, we just talked about the volume of a prism being base area times height. So imagine you had a pyramid with the same base area and the same height. Obviously, it's going to have less volume because it tapers off to a top here like that. The question then is, how many pyramids do you think can fit in here? How many of these pyramids can fit in here? Well, the answer is very interesting. It's exactly 3 pyramids that will fill that. If you had water in here and you were pouring it in here, you would have to pour 3 of these to fill this volume here. So if that volume is base area times height, this volume, or base area times height, in this case, base area is little b times little h, base area times the height, then this volume will be 1/3 base area times height, or 1/3 b times h times height. That makes sense. This volume is 1/3 of that one. This is one of the key formulas for today. Make sure you write that down. Okay, so pyramid volume, 1/3 base area times height. So whatever your base is, you start by finding that area. Here we have a square. Here we have a triangular base. Find that area, multiply by height. Find 1/3 of that, you have the volume. Okay, what about volume of a cone? So we begin with the same scenario. Let's say we have a cylinder and we have a cone with the same circular base and the same height right here. So again, how many of these cones would fit into this cylinder? The answer may surprise you, or maybe not. It's exactly the same as we had when we had the pyramid going inside the prism. 3 of these cones exactly will fit in here. That means if there's water in here, you could pour 3 of these cones of water into here to fill this perfectly to the top. All right, so if that volume is base area, which is circle area times height, pi r squared times h, then this volume is 1/3 pi r squared times height. Again, one of our key formulas for today, the volume of a cone is 1/3 pi r squared times height, 1/3 the base area times height. Okay, there is that formula. A sphere. A sphere is the set of all points in space equidistant from a fixed point, the center. So imagine there's a center and there's all these radii coming out from the center. All those radii have the same length no matter where you go on the surface of the sphere. That's the definition of a sphere. Here's the center, here's your diameter, here's a radius. Here's what is called the great circle, the biggest one of the circles in the sphere. So volume of a sphere is given by this formula. We'll look at where that formula comes from later. Key formula though, write it down. And don't forget that this is a r cubed here, not r squared. All right, now let's talk about surface area. Surface area of a solid is the sum of the areas of all its faces. Think of it as the skin or the outside. So if you add up all the face areas, you have the total surface area. So every 3D solid can be made into a net. So we have this net representing this. So to find the surface area of this, we can think of all the surfaces. We have two bases, and we have this entire surface here, all the lateral areas. So the surface area would be the two bases plus the area of the four lateral rectangles, and that would be the entire surface here. Likewise, in a triangular prism, the net looks like this. So we have two bases, those two parallel bases, and then we have the lateral rectangles. So the surface area is two bases plus the area of the three lateral rectangles. That's the entire surface of this prism. Cylinder works the same way. We have two bases, and the bases this time are these circles. So here's your two circles, and when you unravel the lateral face, it's one giant rectangle. So this time, this circumference of this circle ends up being the length of this thing you unravel in the middle. So when you unravel the centerpiece, its entire length is like the circumference there. That makes sense. And the circumference is 2 pi r. So if that's 2 pi r, and here's our height, so there's our height here, then each of those circles is pi r squared. Then our entire volume, or sorry, our entire surface area must be two bases, 2 times pi r squared, the two circles, plus this length, which is actually the circumference here, times the height. And that rectangle's area is 2 pi r times h. Very important formula. Write that down as well. Now let's talk about the surface area of a square pyramid. A square pyramid has a net that looks like this. So obviously the surface of this one will be one square and four congruent triangles. So one base area plus the area of four lateral triangles. In this case, if we call this x, then this is x because it's a square, and we call one of these triangles congruent to the others, we can say that one has a height of L, because L actually represents what's called the slant height here, okay? So we have L, and now I'm going to take one of those triangles, put it there, take another one of those four, put it there, take another one of those four there, and there's the fourth one. We've created a parallelogram, and a parallelogram has an area of base times height, and the base here is two of those x's, because it's two of those triangles, and the height of this parallelogram is that lateral height right there. So the area of this, of all the triangles, in other words, is 2xl, L being the slant height, which would be a height line along the side of the pyramid here. And this whole surface area then is x squared, the area of the square, plus those four triangles, which is this area here. Write that down and make sure you understand exactly where that formula came from. All right, cones. These are two good looking cones. All right, so surface area of a cone. Here's the formula for surface area of a cone. Pi r L plus pi r squared. Pi r L being this. If you take a cone and unravel it, we have the circle on the bottom, and we have the lateral area, which ends up looking like this. That lateral area is pi r L. L being, again, the slant height. You can see L here. And pi r squared being the circle. So that's the entire surface. Write that one down and make sure you understand how it comes from these shapes as well. That one we'll look into more later as well. All right, and surface area of a sphere, final thing. If you take a long piece of paper that has a length that is the same as the circumference around here, and a height that is the same as the diameter here, then we can wrap that perfectly around any sphere. And we know this length is the circumference of this sphere. So this length of this rectangle is the circumference, so 2 pi r. And we know this height here is the diameter, which is 2 times r in a circle. Multiply those, 4 pi r squared. Very important formula. Very interesting proof as well. Make sure you read this and pause it if you need to. All right, I think we have all the formulas. There's the formula of a surface area of a sphere. There's the main formulas you should know. Memorize those. We're going to work with those soon.